So we, in 30-2, we can only do degree 1, 2, and 3. That's all I can give you. Degree 1 was in grade 10, degree 2 is in grade 11, and then degree 3 is grade 12. And it's cubic functions, which we talked about yesterday. Degree 1 and degree 3, linear and cubic, are our odd degree functions that disco, right? So we had XER, YER. And the smallest degree that they can have is 1, correct? And the largest degree they can have, or the smallest number of x-intercepts they can have is 1. And the largest is equal to the degree, correct? We talked about that? Now, even degree functions, you guys did these in last year, in either whatever class you were in, grade 11. So if I give you this, or I give you this, or I give you this. I want you to tell me the sign of the leading coefficient. I want you to tell me the sign of the y-intercept, the number of x-intercepts, and then the domain and range max min. So in order to give my domain and range, I have to give you something like 6. I'll have to do that one. -3. Okay, fill them all in. Try them all out. So I wrote the sign of the leading coefficient. Where do we look for the sign of the leading coefficient? How it ends on the? Right, yes. So this one here ended down. So it is a negative leading coefficient. Because it's an even degree, I know it's also going to end down on the right or on the left as well. Because even degree end in the same direction, right? They're not discoing, correct? The leading coefficient of this one is positive. It's also up on the left as well because it's an even degree. And the leading coefficient, the sign of this one, is negative. Then I wanted the y-intercepts, the sign of the y-intercept. So this y-intercept is positive, right? Because it's here. And then I want the sign of this y-intercept, which is positive. And then this y-intercept is positive. Does anyone have any idea? That's not positive. It's scary when sometimes I do things. Okay, negative. I was moving on and then just writing. Okay, if we go up here, does anyone know which of those letters represents the leading coefficient? The A. So this one is my leading coefficient, which lets us know how it ends on the right, correct? Does anyone know which one of these represents the y-intercept? The C. 50-50 didn't go well. So this is the y-intercept, which is 0C. Now, we shouldn't have to actually memorize that. It should just make sense why that's the y-intercept. When you hear y-intercept, what should you think? X equals 0. We agree? So if I take this equation, y equals ax squared plus bx plus c, and I want to find the y-intercept, I need to set x equal to 0. We agree? So I would get y equals a times 0 squared plus b times 0 plus c. So my y would equal c, so I would have 0c. So that's why, if there's no brackets, that constant at the back is always your y-intercept, whether it's linear, quadratic, or cubic, degree 1, 2, or 3, because it's the only one without an x, right? And the ones with x's will fill in a 0 and they'll cancel off. All right. How many x-intercepts does this one have? 2. How many does this one have? 1. How many does this one have? 0. So what's the difference between the number of x-intercepts of an even degree polynomial or an odd degree polynomial? Odd degree we did yesterday, which was degree 1 and 3, linear and cubic. Even degree is quadratic. Yep.
Doesn't the odd always have to have 1?
The odd always has to have 1 because it discos, and at some point in time it's going to have to cross through. But the even could have 0 because the arrows are in the same direction. Could be completely below or completely above. Exactly. Okay, the domain of all of these, they're still going out for like to the right and to the left, correct? So the domain of every polynomial, unless it's a word problem, is x such that x is an element of the reals. Okay? What's the range? So for this one, I have a what? A max or a min? I have a maximum, correct? So I'm going to circle maximum or say maximum. So my entire graph is below that maximum or above it? It's below it. What was the highest it went to? 6. So my range is going to be y such that y is, here's 6, and the whole graph is what? Below it or above it? Below it. So I say less than or equal to, and it's equal to it because 6 is the highest I go, 6. Y is an element of the reals. Is this next graph a max or a min? A minimum. So is the graph of, what is it, what's the lowest it can go to for the y? 0 or what? Greater. So I'm going to say y such that y is greater than or equal to 0. Y is an element of the reals. Then this last graph, max or min? It's the maximum, right? It's the highest you could go. It's a hill. If it's a valley, it's a minimum. It's the lowest you can go. If it's a hill or a mountain, it's the highest you can go, right? Like you thought about a mountain, you can go the very maximum of the mountain, or a valley, the very minimum of it. So we're going to have maximum. So it's going to be less than or equal to -3. Little blue box it is. Yeah.
Are we allowed to shortcut it on the test and put max or min, or do you want us to write the entire thing?
I want you to write the entire thing because I don't want anyone losing marks for short form. It's just saving pencil. Okay, then flip over to the next page. What do we have up here? Now it's a quadratic, correct? This one, I'm going to go through the first one with you. So, they want a quadratic. Well, I want a quadratic where a is greater than 0. A is my leading coefficient. So what's that telling me? It's up on the right. I also know it's up on the left as well because these are in the same direction. We agree? So it's up on right because of that, but it's also up on left. And then what about this? What is this? What does that mean? Nope. What's my C? Yeah. So I have a positive y-intercept. So I'm going to make my y-intercept first. Now I need the graph to be up on the right and up on the left. So I could do something like this if I wanted to. Just make sure it's symmetrical. So don't do something like this. That's not a quadratic. Not in a million years. Try and make it symmetrical. What I could have done too is I could have went like this. Could have made the whole thing completely above if I really wanted to, something like that. All of those would pass the rule, right? I need to be positive. Up on right, up on left, and a positive y-intercept. Okay? You guys try FGH. So, this one says A is greater than 0. So I know it's up on the right. And I need to have a negative y-intercept. So, I could do something like this. Right? I just need to know that I need to have a up on the right, up on the left, and a y-intercept somewhere below 0. Correct? Okay, this one, I have a negative leading coefficient, so it's down on the right, and a negative y-intercept. So I could have a graph completely below, something like that. I could have a graph coming up and coming back down. But what I need to know is I need to have down on the right, down on the left with a negative y-intercept. And then this one, it's down on the right and a positive y-intercept. Positive y-intercept is G. Okay, so it could be something like this. Down right, down left. All right. Then we're going to go to the next page. So, there's two matching each graph situations here. I don't need you to justify your reasoning. I just need you to match the graph with the equation without typing them into your calculator. So there's going to be no typing them in. Paying attention. So if I go to do this one here, for example, g of x, I'm going to label one of these g of x. Well, it's cubic. So I know just based on the fact that it's cubic, it's either this one here or this one here. We agree? I've at least narrowed it down to 2. Then I go to my leading coefficient. It is negative. So I need to be what on the right? Down. Here's g of x. I can also check myself because this needs to be my y-intercept, doesn't it? And my negative 2 is my y-intercept. So that does help me out to make sure that I'm actually right. You see that? So your constant at the back is your y-intercept, and this tells you how you end, and then the degree tells you what shape of the graph it is. Okay? So you're going to try and match these two, so these 6 graphs with these 6 equations, and then these 6 graphs with these 6 equations. Try it out. So the other cubic one is p of x, but let's actually prove that's right. So this would be p of x, but let's see why. So I have a positive leading coefficient, so I need to be up on the right, and my y-intercept is negative 2, which is good. Okay, then I want to go to my quadratic ones, which is this or this. So I can use j of x. J of x is a positive leading coefficient, so does k of x. So they're both up on the right. Okay, that didn't narrow me down at all. But I can go to my y-intercepts, right? This one is negative 2. Well, this one has a negative 2 y-intercept. So this one is j of x. And this one has a positive 1 y-intercept. So that one is k of x. So this one's done, and so is this one. So we're left with the linear ones, and this messes some people up, but you just have to watch your slope. So these are both negative, so they're both down on the right, and they both have negative 3 y-intercepts. So that doesn't narrow us down. But we can use our slopes from grade 10, correct? So this is going to be, if I use the negative there, it'd be down 1, because I rise before I run. So I'm going to go down 1, right 2. So if I go down 1, right 2, I'm here. So that doesn't make sense. But if I go here, down 1, right 2, oh, I land on it. So this one is h of x. And then this one is negative 2 over 1. So this is down 2, right 1. So if I go down 2, right 1, I land on it. So this one is q of x. So we can use our slope to narrow them down. Okay? Then we have these ones. All right. So we have our cubics first, which is either going to be B or F. And these are our cubics, this one here and this one here. This one has a negative leading coefficient, so it has to be down on the right. So that's going to be this one, which is just I. This one has a positive leading coefficient, so it's up on the right, so it's this one, which is IB. Now, they both had y-intercepts of 4, so that wasn't narrowing us down, right? No matter what, we still have that same y-intercept. Then we go to our quadratics next. It's going to be this one or this one. If I expand this one out, I get x squared plus 3x plus 2. So this one here, they're both positive and up on the right, so both of them are. This one has a y-intercept of 4, which is this one. And this one is a y-intercept of 2, which is this one. So you can expand it to get it into the right form. Then this one throws people off because they think it has a positive leading coefficient. I could actually rearrange this into the right order. It'd be negative x plus 3. So it actually has, they both have a negative leading coefficient, which is this one and this one, down on the right. This one has a y-intercept of 3, and so does this one, so that doesn't narrow us down. But this one has a slope down to right 1. So if I go down 2, right 1, I land here. That didn't work. Down 2. Right 1, land here, that works. So this one is 6. And this one is down 1, right 1. If I go down 1, right 1, I land on it. So that one is 5. Okay, then we're flipping over. Okay, so number 1 here says use technology to graph. Do we have to use technology to graph? We only have to if it's not in a nice form. Like this one here, we would have to. But also we do have to use technology to get the range if it is a quadratic, correct? Yeah. Yeah. So you have to use technology to get the range because you're going to have to get the maximum or the minimum. I'm going to remind you how to do that. So please type this one into your calculator. Type in x squared plus 4 into your calculator, into your y equals.
Into the graph.
Yeah, into y equals. Okay, everyone type that into y equals?
Yeah.
Then go zoom 6. Just so you know, tomorrow we're going to be using our calculators a lot. If you don't have your calculators, you won't learn all the steps and it will not produce anything for you. So you need a calculator by tomorrow and you can't forget one. And you have to use yours so you know how to do it. So this is my calculator. I went zoom 6 so that I got that standard window. That was a negative 10, 10, negative 10, 10. I just did that so that everyone was kind of in the same spot. Now, if I want to see more of the graph, do I need to go to the right? No. Do I need to go to the left? No. Which is my x min. Do I need to go make my y min bigger? Down here? Do I need to make this bigger? No. Do I need to make my y max bigger? Yeah. So if I want to see more, I could go to my window and make my y max be 20, let's say. And press graph. So it just makes it bigger, right? Now to get our range, we need our minimum or our maximum, correct? If it's a minimum, it's greater than or equal to that. If it's a maximum, it's less than or equal to. That's what we learned last year. Does this graph have a minimum or a maximum? A minimum. So we go second, trace, because that's where we're going to go to calculate. Which one are we going to pick? Minimum, which is 3. Now it says left bound. So we need to be somewhere on the left of our minimum. Anywhere. Here, 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 and hit enter. Then we need to be somewhere on the right side. Here, 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 anywhere. And hit enter. And then what do we do? Enter. Now, guys, I need to draw your attention to this. Some people will say, oh, it's at negative 2.1 and 4. Does that look like negative 2.1 to you? No. What's behind here? E to the negative 6. So that's actually 0.000000213, I lost track. But it's like 0, 0, 0, a whole bunch of zeros. 2, 1, blah, blah, blah. So what is that just? 0. So whenever you see e to the negative, anything that's just 0. So this one has a minimum at 0.4. Do we agree? So the lowest this graph goes is 4 or higher, correct? So if I went to do B, let's say, B asks for the number of x-intercepts. So if I look here, how many x-intercepts do I have? Trick question. None. It doesn't cross the x-axis. So number of x-intercepts, no x-intercepts. Then it says y-intercept. What's my y-intercept at? Do I even need to go in my calculator? No, it's right there. Correct? So 0, 4. As these are your notes, you can do short form if you want. These are this is your homework. End behavior is how it ends. So if I look at this one, it's up on the right and up on the left. But do I need to actually look at it, or can I look at my leading coefficient? It's up on the right, and because it's degree 2, it's also up on the left. So your end behavior is how it ends. So it's up on left and right. What's my domain? Domain of all polynomials is x such that x and m is real, because it keeps going on for life. What's my range? Y is greater than or equal to 4, right? The range is only different if it's a quadratic. If it's degree 1 or degree 3, it's YER. Super easy. Number of turning points. Turning points are max or mins. How many turning points does this one have? 1. So these are due for tomorrow. Number 1. Can be submitted online. This I want the degree, the leading coefficient, and the constant term. So we'll do the first one together. What is the degree of this one? What's the degree of this first one? 2. What is my leading coefficient, which I can use short form for because these are my homework? What's my leading coefficient? 6. And what's my constant? The one without a variable. So what's my constant? -2. So that one's due for tomorrow as well. And then I want you to do 4. Degree, sign of leading coefficient, constant term. So 1, 2, and 4. Okay? They're due for tomorrow.